Today what we are doing in 10.1 is we are going to be graphing square root functions. So we have a little warm up here and it says to make a table of values for each function and then use the table to sketch the graph. So I'm going to kind of move this down real quick because we also have some questions over here. The first one is, can you plug a negative number into x? So if we come over here, okay, let's go ahead and plug in a negative number. So let's say we want to plug in -1. So if we do y equals the square root of -1, well, if we go to our calculators, here's our calculator, and we do the square root of -1, we end up getting an error, okay? Because remember, you can't take the square root of a negative number. So the answer to this first one here is no, okay? You cannot take the square root of a negative. Can you plug 0 into x? So again, if I come over here and I plug in 0, y equals the square root of 0. If we go to our calculators, here's the square root of 0. Oh, let me clear this, hold on. Okay, square root of 0. We can see that it does work. So like, okay, well that one is good. Let me just go ahead and come on down. We're like, yes, we can plug in 0. So then can you plug in a positive number? Well, if we think about it, if we can plug in 0, you can plug in any positive number. So the answer is, of course, yes as well. Now there is another question that says, how could you describe the domain? So we're going to have to graph this first before we can determine. Now what happens is, because we cannot plug in a negative number, it means the first x value we can plug in is 0, and then we can plug in 1, 2, 3, and 4, okay? So if you plug 0 into x, you get the square root of 0, which is 0. If you plug in 1, square root of 1 is 1. If you plug in 2, the square root of 2, it won't come out nicely, and that's fine. So if we do the square root of 2, you get a decimal. Let's just round it to the nearest tenth, so just one decimal place. So it'll be about 1.4. Then we're going to do square root of 3. Again, it's not going to come out nicely, so square root of 3, we get about 1.7, and then 4. So square root of 4 is 2. So now because we have those values, let's go ahead and plot those points. So we will point at 0, 0, 1, 1, 2, 1.4, 3, 1.7, and 4, 2. Now remember, with this graph, you guys can't have a negative value, so you can't have any of those negative numbers. So you start at 0, 0, and then you follow those points that you guys created, and then you guys are only going to have one arrow going in that direction. Now because there is a restriction, which means you can't have a negative number underneath of your square root, that means your domain has to be all of the x values that are greater than or equal to 0. So with the next one, we have y equals the square root of x plus 2. So now it says, can you plug a negative number into x? Now we know we can't have a negative number underneath of the root, but is there a way to plug a negative number into x, which would end up working? So let's plug in -1. So we would have y equals the square root of -1 plus 2. Well, -1 plus 2 is the square root of 1, so we do still end up getting a positive number underneath of the root. So the answer for this one is yes. There are certain negative numbers we can plug into x. Now, can we plug in 0? Well, if you plug 0 into x, 0 plus 2 is still positive. So again, that answer is yes as well. Can you plug a positive number into x? Well, if you can plug 0 into x, then yes, you can plug a positive number in as well. So we'll look at the domain in just a second. Now, for your guys' domain, okay, so for the first number for your x value, you have to look at what is underneath of your square root. So we take the x plus 2, and it has to be greater than or equal to 0, okay? So if we want to find x, you subtract the 2 over, and we get x is greater than or equal to -2. So -2 is the first number that we have to start with, and then we have to count up because it's greater than or equal to. So we go to -1, 0, 1, and 2. So then once you guys have all those x values, then we're going to plug it into our equation. So if you plug -2 into x, square root of -2 plus 2 is the square root of 0. Square root of 0 is 0. If you plug in -1, square root of -1 plus 2 is the square root of 1, which is 1. If you plug in 0, square root of 0 plus 2 is the square root of 2. This one's going to come out to be a decimal. So the square root of 2 is about 1.4. Plug in 1. Square root of 1 plus 2 is the square root of 3. Square root of 3, again, it's going to be about decimal, will be about 1.7. And then plug in 2. Square root of 2 plus 2, square root of 4, square root of 4 is 2. Okay? So now from here, we're going to plot those points. So at negative 2, 0, negative 1, 1, 0, 1.4, 1, 1.7, and 2, 2. Again, we start at that negative 2, 0. We just follow those points. So you create one arrow because it can only go in one direction. So that means our domain, because your first x value you can start with is negative 2, the domain has to be x is greater than or equal to negative 2. So would these two functions create the same graph or different graphs? Why and how do they compare? So your first graph is y equals the square root of x plus 2. The second graph is y equals the square root of x, and then plus 2 is on the outside. Because the 2's are not in the same spot, they will not end up creating the same graph. So whenever you have a number underneath of your root, you either move it to the left or the right. It's always the opposite sign. So since it's plus 2, it means that we would end up moving to the left, negative 2. If you add or subtract on the outside of your root, it means that you either move up or down. So because you are adding 2, it means that we went up 2. So they will end up creating two different graphs. So graphing our square roots. So again, you guys are only going to have one arrow. You will not have two. You will have one distinct starting point. So we have to always determine what that starting point is, which means we have to find our domain first. To find our domain, you take what is underneath of your square root, and it always has to be greater than or equal to 0. So steps in order to graph: 1 is find the domain, 2 is to make a table of values and graph it, and then 3 is to find the range. So example 1, we are going to graph 3 times the square root of x minus 5. So what we have to do first is find the domain. So we take what is underneath of the square root, which is x minus 5, and it has to be greater than or equal to 0. Which means all that we do is add the 5 over, and our domain will be x is greater than or equal to 5. So that 5 is the first x value that we have to use. Because it's greater than or equal to, we're going to count up to 6, 7, 8, and 9. So then once we do that, we're going to plug it straight into our calculators. So if you plug 5 into x, you're going to have 3 and then the square root. Set of x is going to be 5 minus 5. Now what you guys can do is you can plug this directly into your calculators. So if you guys wanted to, plug it directly as it sees. So you would have 3 first, and then you would do the square root of 5 minus 5. And it would give you guys that answer immediately. So I do recommend doing that. And we end up getting 0. So if you plug in 6, 3 square root of 6 minus 5. Again, you can plug it in. So 3 square root 6 minus 5, you end up getting 3. So here's 3, and we are going to do that for the rest of them. So if we plug in 7, I believe it's going to be about 4.2. If you plug in 8, it'll be about 5.2. And if you plug in 9, now just remember, so this is 3 square roots of 9 minus 5. And again, one more time, plugging it into the calculator. So 3 square roots, 9 minus 5 gets us 6. So we put a 6 right here, then we're going to graph it, okay? So 5, 0, 6, 3, 7, 4.2, 8, 5.2, and 9, 6. And again, start with that first point. You're going to follow everything. You will just have one arrow, okay? Now from there, all that we have to do is we have to look at the range. Range always goes off of your y values. So if you guys look at your y values, the first y value is 0, and then it increases from there. So since those y values are increasing, it has to be y is greater than or equal to our first y value, which is 0. Next, again, graph the function. So finding our domain, remember you only take what is underneath of your square root. The +3 is not underneath it, which means we can only take the x, and that has to be greater than or equal to 0. Now, because x is already solved for, that is our domain. X greater than or equal to 0. So that means 0 is going to be the first x value, greater than or equal to, count up. 1, 2, 3, and 4. Now we're going to take each x value and plug it into the equation. So if you plug 0 into x, it'll be the square root of 0 and then +3. So when you guys plug this into your calculators, so here we go, you would have the square root of 0. Because 3 is on the outside, you have to hit the arrow over and then +3, and you end up getting 3 for your y value. So then the same thing with 1. So square root of 1 +3. So again, in the calculator, you do the square root of 1, hit your arrow over, and then +3, we end up getting 4. Okay. So if we plug in 2, we'll get about 4.4. If you plug in 3, it's about 4.7. If you plug in 4, you end up getting 5. Okay, so again, all this can be done in our calculators. So we're going to graph it. First point is at 0, 3, 1, 4, 2, 4.4, 3, 4.7, and then 4, 5. Start at the first point we graphed, follow the others, and create one arrow. So now from there, our range. So the first y value is 3. The y values from there keep increasing. So it has to be y is greater than or equal to 3. Our next one, so graphing the square root of x minus 4. So again, the minus 4 is on the outside of your square root. So we only take what is underneath. So we take the x, and it has to be greater than or equal to 0. The x is already solved for, which means our domain is x is greater than or equal to 0. So we're going to start with 0, count up to 1, 2, 3, and 4. And now we're going to plug it into the equation. So if we plug in 0, square root of 0, minus 4 is on the outside. So remember, in our calculators, we would do the square root of 0, hit the arrow over, and then minus 4. So the first y value is negative 4. Same thing with 1. So square root of 1, and then minus 4. So in our calculators, we're going to do the square root of 1, hit the arrow over, minus 4, and our y value is negative 3. So same thing with the others. So if we plug in 2, so if we end up plugging in 2, we're going to get about negative 2.6. If you plug in 3, it'll be about negative 2.3. And if we plug in 4, it would end up being negative 2. So we're going to graph that. 0, negative 4, 1, negative 3, 2, negative 2.6, 3, negative 2.3, 4, negative 2. Start with the first point and follow that through. Create one arrow. For the range, the y value we begin with is negative 4, and our y values are increasing. So it's going to be y is greater than or equal to negative 4. With the next one, graphing our function, so we have the square root of x plus 5. Now the x plus 5 is all underneath of our root, which means we take the entire x plus 5, and it has to be greater than or equal to 0. So all that we do is subtract the 5 over, and our domain will be x is greater than or equal to negative 5. So the first x value is negative 5, and then count up to negative 4, negative 3, negative 2, and negative 1. Then we can plug in these numbers. So if we plug negative 5 into x, we're going to have the square root of negative 5 plus 5. Because remember, everything is underneath of that root. So in our calculators, square root, negative 5 plus 5, hit enter, and you guys get 0 for your y value. Okay? So if we plug in negative 4, we would get 1. If we plug in negative 3, about 1.4. Negative 2 will be about 1.7. And if you plug in negative 1, we'll get 2. So plotting these points, so we have to go to negative 5, 0, -4, 1, -3, 1.4, -2, 1.7, -1, 2. Start at your first point, follow the others through, you will have one arrow. Our first y value is 0 because those y values are increasing. The range is y is greater than or equal to 0. Now what we have is we have transformations as well. So you can either be moving to the right or the left. So whenever you guys have a number underneath of your root, that's when we go to the right or the left. It's always the opposite sign. We go up or down when we are adding or subtracting behind the square root. You will have a reflection when there is a negative. That's the only time you guys will have a reflection. You will have a horizontal stretch or shrink when there is a number inside of your root attached to the x value. You will have a vertical stretch or shrink when a number is on the outside of your root. So just like with a quadratic, when we did this in chapter 8, we also have to do this now with our square roots. So example 4, we are going to graph the function and then we are going to compare it as well. So what we have is negative square root of x minus 2. First, you have to find your domain no matter what, even if I don't ask for it. So we have to take the x minus 2 and have it be greater than or equal to 0. So if we add the 2 over, all of the x values have to be greater than or equal to 2. So we would plug in 2, 3, 4, 5, and 6. Now from there, we have to plug it into the equation. So if you plug in 2, it'd be negative square root, and then 2 minus 2. And again, you guys can just plug it into your calculators. So we would do negative, and then square root, 2 minus 2, you end up getting 0. So first y value is 0. If you plug in 3, negative square root, 3 minus 2, plug it into our calculators. Negative square root, 3 minus 2, you get negative 1. Sorry, that looks like a plus. Negative 1. Okay? So if you plug in 4, it'll be about negative 1.4. 5 will be about negative 1.7. 6 would be negative 2. And then we're going to plot those points. So 2, 0. 3, negative 1. 4, negative 1.4. 5, negative 1.7. 6, negative 2. So now again, we start at that first point and we follow the others. In this one here, it is flipped in the opposite direction, and that is okay. So what happens is now we have to compare. So these are the transformations. So you guys have to think, okay, if I have the square root of x in the equation that we just graphed, what is different? First, what is different is there is a negative in front of your root. Remember, whenever there is a negative, it automatically means that there is a reflection. It's also a reflection because you guys' graph shifted over, right? Instead of going up, it's now going down. We also have an x minus 2. So remember, inside of your square root is when you either move to the right or the left from the origin. So we can see here that our first point is not at the origin, but it moved to the right, which just means that we went to the right 2. Our next one, again, we are going to graph the function 3 square root of x minus 2. So this one's a little bit more tricky. So again, you have to find your domain first. So if you look at your square root, it is only x that is underneath it. So that has to be greater than or equal to 0, which means we'll start with 0 and then 1, 2, 3, and 4. Okay? So if we plug 0 into x, we're going to have 3 square root of 0 and then minus 2. So pulling up our calculators, 3 square root of 0, you have to hit the arrow over and then minus 2, and you end up getting negative 2. So negative 2. If you plug in 1, 3 square root of 1 minus 2. So we have our calculators, 3 square root of 1, hit the arrow over, subtract 2, you get positive 1. So here's 1, okay? So if you plug in 2, it's going to be about 2.2. If you plug in 3, it'll be about 3.2. If you plug in 4, it'll be 4. So graphing 0, negative 2, 1, 1, 2, 2.2, 3, 3.2, 4, 4, Start at your first point, follow it upwards. Now what we have to do is we have to compare with the graph of just square root of x. So we can see here that 3 is a new number. That's not in the original. Whenever we have a number in front of the square root, it is either a vertical stretch or a vertical shrink. Because the 3 is larger than 1, it is going to make it a vertical stretch. Okay. Now we also have this -2. And because it's behind your guys' square root, it either means that we went up or down from the origin for that first point. So if you look at the origin on your graph, you see how your first point went down. So it just means that we went down. I put -2, but if you guys just want to put down 2, that's going to be correct as well. Now in our last example, what we're going to do is find the domain of the functions without graphing. So it's just going to be our domain. With the first one, we have y equals the square root of -x. So remember, your domain, you only take what is underneath of your square root. So we just take the -x and we want it to be greater than or equal to 0. So if x has to be a positive, we need to divide by a -1 to make x a positive. And remember that whenever you multiply or divide by a negative, you have to flip the inequality. So it has to be x is less than or equal to 0 divided by -1 is 0, and that's going to be our domain. With b, we have y equals square root of -x plus 1, and then -3. So again, you only take what is underneath of your roots, -x plus 1, and we want it to be greater than or equal to 0. So we're going to get x by itself. Subtract the 1, so -x is greater than or equal to -1. Sorry about the vowel here, guys. And then divide by -1. So we end up with a positive x. We have to flip the inequality to less than or equal to. -1 divided by -1 is 1. And that is going to be our domain.